when we're looking at this, we just use our fraction knowledge and we can split it up. So I hope you won't actually write this ever again, but I can separate that to be thusly. And now I simplify, so x squared on x squared is 1. I can rewrite this to be 4x to the minus 2. I mean, ideally, you should be able to just look at that and go straight to. Okay? Now we will differentiate. So we'll go dy by dx. Derivative of a constant? Nothing. We differentiate. This minus 2 times minus 4 is positive 8. And then we've got x to the minus... Oh, hello, where did that come from? I don't know. To the minus 3 because we take 1. Okay? Now, earlier when we were doing some of these questions, I said don't bother simplifying. In this case, because we're going to substitute in, I will ease my efforts. I won't even have to go to the calculator. I can go 8 over, put that downstairs, and now I'm going to just slap in my x value. Okay? So when x is 4, we end up with that's 8 over 4 cubed. 4 cubed is 64, and so that becomes 1/8. And I would like to think you can do that faster than getting your calculator, typing it all out and popping it in. Would we agree? It is the same thing for h. Would you like me to do it or not? We're okay? Excelente. Just have all the skills to be able to do it. So just because you haven't done one like this before doesn't mean you should down tools or go, oh, I don't know what to do. First thing, we should have the headset of, I need to do something, right? What can I do? So we're reading. What does this actually, this is telling you to do something. Right, it's saying go to your f function here and wherever x is, replace it with 2. And when you do that, it will give you an answer of 4. So I'm going to say 4 equals 2 squared plus b plus 1 times 2 plus 2c. Can tidy it up. So 4, oh dear me. 4 equals 4 plus 2b plus 2 plus 2c. What could we do here? They cancel. Okay, I've got, could pull out or divide through by 2. So I get b plus 1 plus c. Are we happy with that? And then I'm stuck. I go, okay, well, I've got that far with that bit of information. Now we're going to look at the next bit of information. What's the first thing you're going to do when you see that? Excellent. When in doubt, just differentiate. Even if you did nothing else, differentiate. So here we go. F dashed of x. The first bit, 2x. Love it. What about the next bit? B plus 1x. Isn't b plus 1 just its coefficient? And if you were stuck, if you're going, what do I do? Do this. What if you had 4x? What would you say is the derivative of that? 4. Then maybe think about, what if I had 10x? What's the derivative of that? Just 10. So I've got b plus 1x. It's just b plus 1. So I'm going to say 2. Oops. Bugger. I'm not on the money today. Like my board, I'm a little bit tired. You get back there, board. Okay, so 2 will equal 2x. I'm going to say that equals 2. Right, 2x plus b plus 1. And what do we know about 2c? 2c or not 2c? A sailor went 2ccc. It's a constant, yeah? So what's the derivative of a constant? 0. So I've got that. You're right, x is minus 1, so we've got 2 equals minus 2 plus b plus 1. 4, take 1, so therefore isn't b 3? It means you can now sub it back in here, and you should be able to find c. So be honest with yourselves. I don't need to show of hands or whatever, but I would bet there's a few people in here who looked at that, went, ooh, can't do it. I'm not even going to try. It looks too hard. Was it that bad?
I tried my best, but
Not that bad. So if you got stuck, I'd be saying, think about how you're reading your mathematical notation. Okay? Do we need to make any notes? Okay. Unfortunately, I am going to leave you with 7, 8, 9, 10. If you haven't done those, you're probably going to leave a column, and you could finish those once I've finished my little spiel. Okay? I'll come around, or you can come up to me and ask questions, but I do just want to get started on the next bit because I know there are some people who have indeed finished. You've seen tangents, I think, before, things that glance, but the key here is they are straight lines. This whole exercise is going to be asking you, please find the equation of these straight lines. We've done this before. What two things do we need to find the equation of a straight line? Point and a slope. They will give you the point. How are we going to find the slope at a point? The derivative. Exactly. So it's stuff that we've already done. We're just going to add in this first application of then finding the tangent. Agreed? So I'm just going to remind you about some stuff. Now, you are more than welcome to go and have a look at some of the little equations that the textbook does on how to get the equation of a line, but I like to stick with the good old try true, use my slope formula. So I'll show that. By all means, read the examples, go and have a look, and if you prefer that, go for it. I can't stand it. I won't judge you much. We read the question. As soon as it said, find the equation of the tangent, we're going, yep, tangent we know is a straight line. We need slope, we need point. We know the slope of the tangent is going to be the derivative. So we derive. It's a lovely expression to derive, isn't it? So simple. So dy by dx, what is the derivative of x? Excellent. 1. Negative 4x. Beautiful. But we want it at x equals 2. So we say when x is 2, dy by dx, 4 times 2 is 8. 1 take 8 is minus 7. So huzzah, we've got the slope. Halfway there. We now want the point. We've got x is 2. Oh, I don't have a y value. If only there was something there that said, oh, y equals this. Blakey boy. The start of the equation, right? All the way here. Y equals. So we are going to be bold and we're going to slap 2 in there. So we get y equals 2 minus 2 squared is 4. 4 2s are 8 plus 3. Even though the weekend is looming, we do that in our heads, not our calculators, and just to work our brain, all right? What is that? Minus 3. Agreed? So nothing new there. Would you agree? It's what we did in the previous exercise. And here comes the next non-new. It's the revision. How do we find the equation of the line when we have the slope and a point? Now, you can use the examples in the book. You can use the whole y equals mx plus c and substitute it in. But when you get fractions, as you are going to with the slope, using your slope formula is the best one. So remind you, we do this. Minus 7 over 1. Yeah? Equals, what's our slope formula? y1 take y2. So it's going to be y minus my y value. So plus 3 all over x minus 2. And now we happily cross multiply. We're going to do the cross multiply thing. So minus 7 times 7. No, minus 7 times 7. Minus 7 times x. If you know that you're a bit of a shocker with not expanding everything, then include brackets. If by now you are pretty good and you know negative times a negative is a positive, then don't bother. It's at this point you make a decision. Are you going to put it in general? Oops. Are you going to put it in general form, or are you going to put it in y-intercept form. Do we remember the difference? Yeah, in this case, I would agree. I would go for y-intercept. So general form is ax plus by equals c, and you try, well, not try, but you make the coefficient of a positive. In the y-intercept, slope y-intercept form, it's just y equals mx plus c, correct? So with this one, I'm going to put the 3 over, so it becomes minus 7 plus 11 equals y. I don't want the y on the right, so equals y. Okay, C now. So you're going to do BDF, I'm saying into the recording now, later. Y equals x cubed minus 5x, and x equals 1. First step, differentiate, baby. That's right. dy by dx, 3x squared minus 5. Good. We make x equal 1. Therefore, dy by dx, aka the slope of the tangent, is going to be what? Not 2? Negative 2. Like the first one, I don't have the point given. I do, though, have my x value. So what is my point? I mean, really, I walk into class sometimes. What is my point? The week has gone. What was my point? 1 take 5, right, minus 4. She's losing the plot. Losing the plot. Did she ever have it? Some of you are saying. Okay, and now we go into, let's find the equation of the tangent. So my slope, I'm going to go minus 2 over 1 equals y. Take 4, which becomes plus 4 all over x take 1. Cross multiply, minus 2 times x, minus 2x, minus 2 times minus 1 plus 1 times, oh nice. Yep. Get y by itself, so that'll be minus 2x take 2 equals y. We are done hither. I'm going to remind you, we can do all of this on the calculator. If it didn't say show algebraically, you could get every single answer here on your calc. So let's start with, ooh, good one. Let's start with, did she just swear? So into the run mode. So newbies, when you turn your calculator on, find your on button, it's over here. Has everyone got a calculator, by the way? Who doesn't? Right. So, oh, did you fix yours, Blake? Okay, so turn it to press menu, and you should get this screen. We press 1 to go into the normal run mode. David, you are irritating me. Just a heads up. Right, we're going to go to option. Hi, kids. Option. We went to calc. What are we going to press? dy dx. Okay, let's do this one over. Actually, we'll do the one over there so I can probably see it. Okay, so we're actually going to put that in. So we're going to go 3. Here's your fraction button. X. Okay, and minus 1 over x squared. So it's going to be 1 fraction button. Oh dear, don't do that. I forgot to put my plus. Oh, my minus. So, oh, geez. Come on, Friday. Minus 1 over x squared. And then we can move our little arrows. And we've got minus 1. Enter. Check. We got minus 5. Huzzah. But that didn't give us the equation of the tangent. Who remembers how to get the equation of the tangent? All right, so here we go. Menu. We go into the graphing mode. We have a graph here, so you could delete it, but I'm just going to type straight over. So 3 over x minus 1 over x squared. They probably don't know where the X button is, Fletch. Before I graph anything, what should I now set my scale to? Standard, so we're going to go Shift View Window, Standard, it was already set to that, press Exit. I draw, I get that. What a funky looking graph, love it. Okay, I'm about to get the tangent drawn. Mix, have you done this? Looking out the window isn't going to help. Jack, assist. If you have borrowed a calculator, if you have reset your calculator or put new batteries in, you need to make sure that you check you have your derivative on. How do we check our derivative is on? Excellent. Shift, menu, scroll down, and you want to make sure your derivative is on. Okay, if it was off, you just press F1 and you pop it on again. We press Exit and we go back. And again, those people who are talking, helping each other, lovely. Those who are just talking to chat, don't. We graph. Here comes the fun. Who remembers how we get our tangent? That's right. So we want to look for sketch. Who said sketch? So sketch is here. Shift, sketch. And lo and behold, tangent comes up. We press tangent and we get error. Sorry, Fletch. Fletch, can we just hold on for a minute? When I press tangent, I get error. Why? Look at what it's saying. X is 0. Now, what happens when X is 0? You're dividing by 0, and we know we don't like that. Now, we didn't want 0 anyway. What did we want? X is? So as soon as you actually type in, you just go minus 1. Oh, it comes up. Didn't register my negative. Oh, dear. Negative 1, it comes up with the X value. Yes? You press enter. It gives you your derivative. But here's the good stuff. You press enter again, and it gives you your equation. Pretty snazzy? So you can go back and check that, and you should be able to do it really quickly. Oh. Now, I'm 10 minutes over. The very last bit. Sorry, guys. Last bit, and then we can come and go through. You're going to work your way through. Question 2. Just wait 2 seconds. Jacko. Question 2. You're repeating. The only difference now is you're finding the equation of the normal. What's the normal? It's perpendicular to your tangent. So if I wanted to say, let's find the normal to this, that's the only thing that changes. We still differentiate, we still substitute, we find the slope, but for the normal, what do? Flip and reverse the sign, the negative reciprocal. Is the point the same?
Yes.
Yep, absolutely. So really, nothing to see here. You are going to continue. Find the equations of horizontal tangents. Horizontal. What's the slope of a horizontal line? So you differentiate and you make it equal to 0. Solve. So you can now carry on. Finish 6, 7, 8, 9 from the previous, and then carry on with 15B, doing all questions, please. Thank you. Love you. Goodbye.